A long straight wire PQ carrying current 60 ampere. This is wire PQ. It is carrying current 60 ampere. Is fixed. This wire is fixed. A long straight wire PQ carrying current 60 ampere is fixed horizontally. It is fixed horizontally. Another long straight conductor XY kept parallel to PQ at a distance. This is XY. This is placed at a distance. Millimeter. Another long conductor XY kept parallel to PQ. This is PQ. ये PQ है मेरा हाथ, ये XY है मार्कर XY ये रखा है ऐसे करी जे करंट आई तो डायरेक्शन विल बी अपोजिट. Why? Same direction. We have already done. There is a direction. So opposite direction, so that there should be repulsion. ये यहाँ ऊपर ये नीचे है कि एक ऊपर रखा है गिर जाएगा ये तो there should be repulsion. So direction of current is opposite to this direction. Again, PQ carries current I is 60 ampere. Say it is I1. Another wire XY, it is carrying a current I. So the current should be in opposite direction. This is at a distance 4 mm. Calculate magnitude and direction of current. Magnitude, we will calculate direction. Opposite to current in PQ. This is first answer. Direction. Again listen. A long straight wire PQ carrying a current 60 ampere. Another wire XY placed. This is fixed. This is another wire in air at a distance 4 mm. We have to find direction and magnitude of current. For direction, if same direction attraction, so this wire will fall. So the direction of current is opposite. Calculate magnitude and for which magnetic repulsion just balance weight. Here weight will act. So the force should be repulsive force in opposite direction. When they balance, F will be equal to mg. Given mass per unit length is this. We know F, mu naught, I1, I2, 2 pi r. This is what force per unit length. It is 4 milli. This is force per unit length. This is force on length L. Say this is length L. L. We have read force per unit length. mu naught I1 I2 2 pi r. So force on this length is this. Now F is mg. Why? According to question, F mu naught I1. It is not I2, it is I. I1 I L 2 pi r mg. We have to calculate I. I will be mg 2 pi r L mu naught I1 now everything is given. Mu naught 4 pi 10 to minus 7 SI units. M by L ten की minus 2 kilogram per meter. R 4 milli. So 4 10 की minus 3 meter. I1 60 ampere. These things are given. So M by L minus 2 G. Say 9.8. It is 2 pi. It is R. R is 4. 10 minus 3. Mu naught. 4 pi. 10 की minus 7 I1 60. Two. This one multiply 2 with this minus 5 plus 7 60 by 6 0 goes with this ampere. In opposite direction. So what we did, this is force per unit length, this one, and this is force on length. And what is given? It is just balanced, then the weight will be equal to force on this wire, equal and opposite, so it won't fall. Another question, a proton falls at a distance 5 mm parallel to current carrying conductor as shown. Find force on proton. This is a conductor, it is carrying current 20 ampere as shown, and this is what a proton. It falls, and this is the velocity. The proton falls as shown. So there is velocity, this is current in this conductor, and it is at a distance 5 mm. 5 millimeter. A proton falls at a distance 5 mm to current carrying conductor as shown. How it falls? This means this is the velocity, this is the current as shown. Find force on proton. Now here charge of proton. Distance 5 mm. I B force on moving charge. Force on moving charge. QVB sin theta. If this is the direction of current, then this will be perpendicular direction of B. तो B find out करिए पहले. Force अपने आप आ जाएगी 90, perpendicular 90. So it is or Q given, V given, find B from any formula. Now we know B due to long straight conductor, mu naught I 2 pi R B mu naught. This is value of mu naught I. Pi R it is 2 4 it is 8 Tesla. This is B. Now force QVB sin theta. This is I, this is B. So theta 90. QVB. Q V B 3 means 22. 10 minus 4 into 10, 10 minus 3, 22. 8 into 1.6. Watt, Newton, and force is repulsive. Why? ये अपोजिट डायरेक्शन में करंट हो गया, अपोजिट में सेम डायरेक्शन करंट वी हैव ऑलरेडी डन अट्रैक्टिव अपोजिट डायरेक्शन सो द फोर्स विल बी व्हाट रिपल्सिव. A rectangular current loop, size this, carrying current this. A rectangular current loop, carrying current 10 ampere, size this. Again, a rectangular current loop size this carrying current 10 ampere placed parallel to long straight conductor carrying current 20 ampere at a distance 2 centimeter. Find force on current loop. Given I1 10 ampere, I2 20 ampere, R1 this size, this distance to 10 की minus 2 meter, R2 this distance, this it is 4. This distance to this distance is conductor का mu naught 4 pi 10 की minus 7 area 2 into 4 centimeter square 8 into 4 meter square. No need. This length 4 centimeter. Not this length. This length not required. Let ABCD is current loop. It is placed parallel to this current. This length we won't require this length. Why? Just see. Force on AB and CD is 0 as they are parallel to B. Where is B? This is a current, long straight conductor. This is direction of B, perpendicular. B is perpendicular to direction of this current. So this is direction of B. AB and CD, they are in direction of B, so force is 0. Now force on AD, that is F1, U naught I1 I2 2 pi r. This is force per unit length, आर्टिकल था, लेंथ और मल्टीप्लाई कर देते, इट इज फोर्स नाउ. फोर्स ऑन एडी, U naught, it is 4 pi 10 minus 7 I1 10 I2 20 L. Length, it is 4 10 की minus 2 2r r1, this distance say r1, it is 2 pi r1 2 centimeter, so 4 pi minus 2, it is 8. 1020 minus 7 10 raised to power minus 5 watt Newton. Direction, opposite direction of current, opposite, like direction attract. The force is repulsive. This is F1. Force on BC, that is F2. Again mu naught I1 I2 L 2 pi R2 mu naught I1 I2 L 2 pi R2 is this distance, 2 plus 2 4. This will be half of this if you solve it. Newton. Direction same. Current, direction current same. So attractive. Net force F1 minus F2. It is what? 8 minus 4, 10 की minus 5, it is 4 Newton. Which is greater, repulsive, so net force is repulsive. Torque on rectangular current loop. placed in uniform magnetic field. This is the question. We have to derive expression for torque on current loop which is placed in uniform magnetic field. This is uniform magnetic field. This is a current loop. U, X, Y, Z. Say this is direction of current in this current loop. Let current loop U, X, Y, Z carrying current I ये डायरेक्शन करो इसकी. Let a current loop U, X, Y, Z carrying current I is placed in magnetic field B. R U, X, Z, Y parallel to capital B. It is B and this length is parallel to B. Arm X, Y, U, Z, the length is L perpendicular to B. This is B, this length is perpendicular, this length is parallel. Force on UX or ZY is 0. Why? Parallel as parallel to B. Force on XY, that is F. I L B sin theta, that is 90. Length is L, current is I L B sin theta. A direction of current, this is B, this is force outside. Fleming's left hand rule. Force on UZ, that is F. Again it is ILB inside. Why? Fleming's left hand rule. So current loop will rotate, hence torque, that is tau. Outside force, out, in, so it will turn like this, out, in, force into perpendicular distance between forces. It is ZY. Force on Z like this, force on Y like this. Say the deflection or rotation is theta. This is 90 angle. Theta deflection. Force F, perpendicular distance, this is force, this is perpendicular, this is force, this is perpendicular. ZT by ZY cos theta. ZT ZY cos theta. ZY is B cos theta. F ILB small b I L into B N I A B cos theta. This is torque, but torque is vector and it shows scalar. So alpha is this angle, torque, where what is n here? Number of turns. One turn, two turn. This is for number of turns. N I A B cos 90 minus alpha. Why? Theta plus alpha is 90. So torque N I A B sin alpha 2. Torque N I A cross B third. This torque NIA is M cross D. This is torque on current loop placed in uniform magnetic field. This is M. Here M, NIA, it is magnetic moment of current loop. What is this magnetic moment of current loop? We will read it later on. This is current loop. It is carrying current I. This is area. It was found that capital M is directly proportional to I, directly proportional to A, M. IA, NIA. If one turn is there, what is this? N is a constant. It is a number of turns. For one turn, N is 1, 2, N is 2. Though it is constant but depends on a number of turns. This will be the direction outside here. Right and thumb rule लगा के B की direction देख ली हमने. So this is what torque on current loop placed in uniform magnetic field. A 3000 Gauss magnetic field is plus Z axis. A rectangular current loop size 10 centimeter, 5 centimeter, carrying current 10 ampere as shown in figure first, second, third. find torque. Which figure represent stable equilibrium? X, Y, Z axis. This is direction of B. Magnetic field plus Z axis. Figure first. Second, this is B. Figure second, figure third. This is direction of B. This is figure third. Again, this B is 3000 Gauss. Tesla. Three Tesla. Area 10 into 5. Centimeter square. So meter square. Number of turns 1. First case, torque. Find torque. I is what? Ampere. NIA I10 area vector normal it is J. This is the area. Normal to area is normal. Area vector क्या होता है? Normal to area. This is area vector always. Cross B. B is Tesla. It is along Z. Z means K. Point goes with this. J cross K is I. I 5 minus 2 torque Newton meter, and it is what? I. Torque is along this. Second, torque I A cross B. I same, A same, B same. A. Figure second A. J. B. Okay. So same answer. Means x-axis and Newton meter. Third, again torque I A cross B. I A B. A. Normal to area. Normal to area. K. K. B. K. K cross K. So torque is 0. Stable equilibrium. Figure third represent stable equilibrium as torque 0 or M and B in same direction.